Welcome to the 123rd video in our series about Unix tools. In this video, we will look at a mysterious 2012 archive, some more, and see if we can get the code stored within it to run. In video 122, we worked on fred.py, and this time we'll look at the fred.rex program instead. Let's do it. You may not know about REXX. REXX is a mainframe language and is really a good scripting language. It isn't well known outside the mainframe world because for many years there was no free implementation. However, there is a good one now called Regina REXX. It's arguably as good as the mainframe version, and it works on Unix and many other places. So no excuse not to use some REXX. So the first thing we need to do is find out, do we have REXX? It says no, you can install Regina REXX. So before we install Regina REXX, we should find out what version it is. And they say, oh, I've got that. Here's the Regina REXX interpreter. We'll use a show, and the show scrolled it off. But if you scroll back a little bit and you hunt around, it'll take a minute, but you'll see they've got version 3.95, maybe patched a little bit. Well, is that the latest version or not? You know, we found some problems in earlier videos where the version available on Ubuntu, and I'm running the latest Ubuntu, 24.04.1 long-term stable, sometimes their code is old. So we should go to this website and see what version is available. So we pop over to our browser and we jump to that website and we see Regina REXX interpreter. And the first thing we see is 396. Now wait a minute, this was 395 and some patches. Okay, so we don't want the one from Ubuntu, it's too old. Okay, it's too old. We want the new stuff, I'm pretty sure. Let's click on that and see what we see. Bugs fixed. Wow. At least a dozen bugs fixed. I don't want to have to ask myself every time I see a bug, is the bug in the Regina or is the bug in my code? I want the best Regina I can get, and then if I see a bug, I'm pretty sure it's in my code. So, okay, we need to figure out how to get Regina 396 and build it from source. We probably need to click on download. So we click on download and we take a look. And nope. Yeah, there we go. Regina REXX 396. That's the one I want. I click on that. And oh man, look at all this stuff. They've got some pre-built Debian things, but they're not 24.04.1, they're for 22.04, and after, here's some 24.04s, but they're not 24.04.1s, and after all the hard work upgrading my Ubuntu, I don't want to go put some old Debian thing in there. Okay, I'm going to build from source. I'm pretty determined, but I have to find it. Okay, so there's a bunch of stuff. That's stuff for Debian. This is stuff for Ubuntu. This is stuff for the Windows world. Here's RPM. You know, we're looking for the tarball source. There it is. Bam. There's one. 2.7 megabyte. Here's a tar BZ2. It's only 2.5 megabyte. So this one is smaller and it's still the source code. And then, you know, yes, it runs almost everywhere. They got Apple, they've got Alpine Linux, they've got Fedora, Syntax. These guys, they love you. They build one for almost everybody. The problem is it was released in May 5, and in May 5 there was no Ubuntu 24.041 yet, so they couldn't make a package for it. Not their fault. If it was there, they would have made a package for it, I'm pretty sure. So we're going to grab the source. So you click on that, and it's going to download. And here's my stuff. I'm going to say, okay, put it in my downloads, outgoing, and I save it. After I've done that, that was saving it on my Windows machine that I'm using. So how am I going to get that onto my Ubuntu remote machine? And if you remember way back in the first 4 or 5 videos, I talked about PuTTY, and I talked about it had other tools. And if you don't remember, don't worry, I'm going to show them to you again because we need it. There was a tool called PuTTY Secure Copy. And then we have to give our port number and our IP number. But we also need a user, don't we? So my user is John. And we're going to just upload to the temp. And then we'll copy from the temp to our user. Or we could upload straight to our user. Maybe that's easier. And you say, what are we uploading? I need to put the file name in there somewhere, right? So here's the file name, and it goes there. So PSCP, any kind of options you need, then, we're mapping this port to port 22, and then you would normally use port 22 if it was a normal Ubuntu machine. And then we've got the file we want to send, user at IP, or if it was in DNS, you could use a real host name, and then a colon. And if you don't put anything after the colon, it's going to go in the John user home directory. That's what we want. You're going to get a lot of stuff about complaining, maybe. We don't want to update the cache key. That should be that. So I have so much faith. I'm going to close the command window, and here I am. I'm going to look in my home. Minus LARTD. We'll put the last file at the end of the list. I only need the last 10. This is the file right here. So I need to unpack that and build that thing from source somehow. And we just have to hope that it's written in some normal language and not, Haskell or OCaml or something that's just a nightmare. We hope it's written in C or C++ or something normal. We don't know. So let's come back up to our Wednesday and let's unpack that thing. So step 1, don't forget, make sure it's got a top level directory. So we'll do the test. Looks like it does. Regina REXX 396 is the top level directory. Hold your space bar. Yeah. And if we look at it, some of it's written in REXX. That's kind of scary. But we've got some stuff in C. .C, we like that because every Unix system can build C code. Okay. Let's use X for extract. What have we got? Well, we've got so many files it doesn't really fit. But there's one called install, which we ought to read. Installing Regina with root access. That's not us. Okay? Installing Regina without root access. That's us. And they have a prefix home. We're going to do like home.local. Okay? But it looks like it's Kado Auto Tools, or it's supposed to look like it. It's got a configure and a make install. Okay, shouldn't be too bad. We've done that before with several things. There it is. It's got a configure in. This looks like a normal automake thing. So what we do is we say configure, and we do a help, and we put the output somewhere. I'm going to stick to my habit. I always put it in snot. I know that's not a wonderful name, but at least it's not, dirty word or anything. And I'm going to look to see if there's anything I need to worry about. This stuff is standard boilerplate. We're going to use the prefix. We look at this. Is there anything in here we need? Well, we want to make sure we're 64-bit for sure. And the rest of it we're going to leave alone. We care about prefix, and we care about this enable 64-bit, and I think that's all we need to worry about. So let's configure, if I could spell it right. I can't remember it. Enable 64-bit. There we go. And we need to do a prefix equal home.local, like we did all those other packages. And if we don't have some library or headers we need, it's going to tell us. Okay, it says it's going to do 64-bit. It's going to go in home John local. So to build the Regina binaries and dynamically loadable libraries, type make. I like it. It's going to give a lot of warnings. You just have to have a strong stomach and say warnings are okay as long as it doesn't crash. The reason for this is because the GCC compiler keeps getting stricter and stricter and stricter. And code that used to compile clean doesn't compile clean. You see, this was released 5 months in May, and right now it's September. So yeah, about 4 or 5 months ago, and that's long enough that all these warnings have cropped up. It worked. So let's try and make sure that there's some kind of Dester support. There is. So that means this is genuine autocomp. This is not some fake stuff. So let's do a make -n install. The N is for the dry run, and see where it puts things. Home John local. Yeah, I'm happy with that. Looks good. So I'm gonna remove that, and it should be ready. So how can I test it? Well, I can't test it in here because it might get confused with what file's what. But here, if I say REXX version, I get Regina REXX 396 from April. I thought it was May, but it says April here. Okay, we've got REXX. Let's go back into Fred's stuff. And you saw how easy that was to build and install from source. I don't know why people, they seem frightened about it. Most of the time, it's pretty easy. If the upstream provider of the code is a nice group of people, it's just going to work. So let's do REXX, fred.rex. Look familiar? E, simple.txt. L, let's do an H just to test that. Okay, let's try the problem ones. 4 - 2. Worked. No, it didn't work, and it didn't give an error, just like Python. Okay? But look at the output. That's not good. Okay? That's not good. We had 5 lines, and after we delete some, we have 6 lines, and the last 4 lines are all the same. So clearly, there's a bug, and it's not like the bug in the other 2 programs. So there's problem number 1. D3, that broke in the C program. Okay, it works in this program. And it worked in the Python program. Okay, what's another problem? Well, doing E with a file that doesn't exist. You can see we got no error message, but it wiped out the buffer. Okay, each one of these programs has bugs, and they tend to be on the same commands with the same bad input, but their response to the bad input is different. You know, C core dumped, Python stack traced for this, and REXX just said, meh, whatever. And he cleared the buffer, and he didn't give any message at all. So clearly we've got some debugging to do. But can we use GDB on REXX? And the answer is no, you cannot. GDB does not work on REXX. So we're going to have to debug by adding output, some kind of print output, or staring at the code and thinking hard. So we warmed up with the other two. We're ready for this. What does REXX code look like? I haven't showed you the file yet. Okay. It's written by the same moron who is speaking to you now. And of course, this was another one of the class examples designed to get the students to look at a program that's almost done but is buggy, find the bugs, and fix the bugs. So it is GPL, it's open source, you can do what you need to do. And you notice that it starts at the top. The Python code is structured with the main at the bottom. The C code is structured with the main at the bottom. But this REXX code is structured with this do forever loop and then an exit 0. And all the subroutines are after that. So this program looks upside down if you're used to C or Python. But okay, whatever. And what does the code look like? Call char out. And then you see I got the greater than. That's how I print the prompt with no new line. How did I get input? I got to use this parse pool thing. And that's how you get input. So this line, char out, is some kind of print and don't put a new line. Parse pool is some kind of input from the keyboard, normally. And then we've got a big switch statement, one for each of the choices. You know, we got the first char with a substring function. We didn't use subscripts like you do in Python and C. Instead, you have to use this substring function, and it says start on 1 and give me 1 character. So you can see this has 1 based counting, not 0 based like C and Python. Okay, no big deal. It still looks pretty normal. And when you see this substring command 2 and there's no number after it, what does that mean? That means start on the second character to the end, and that's what we're going to have, and the strip will remove any leading or trailing spaces. So this would be the range or the line number that you sent in. And help doesn't take any arguments, so it just ignores it. Wonderful. I think we need to decide what bug we want to fix first, and probably that E loading is the easiest bug to fix. So let's take a look at that. When they said E, it called something called edit CMD. Okay, and so we need to go find edit CMD. Start at the top, look for edit CMD, and there it is. And it looks a little weird. This part, which I'm going to highlight, that is a subroutine in REXX. Subroutines in REXX are a little weird because they, how can I say this They are not strictly functions that always return a value. They are not strictly procedures that never return a value. You can actually return a value sometimes and not return a value sometimes, and that is okay in REXX. And the caller has to be smart enough to figure out if any data is coming back. This is closer to assembly philosophy. Okay, let's look at this code. Okay, procedure, expose lines, we're not sure what that does. I'm not sure we care right now. We're just trying to figure this out. Length, I think we can figure out what that is. And parse arg, we already saw parse arg to get keyboard stuff. This is getting some parameter and putting it in a variable called file name, and they check the length. And if the length is less than 1, they're going to actually call char out and prompt you and get a file name. And you notice they don't check if the second time around it's empty. Oops. Then they call this lines function, and the lines function will read file name and give the count. Okay, the C says, tell me how many lines are in that text file. Better be a text file. So we can find out how many they're going to be, and then we do this do count end. And this is a loop that does it exactly count times, and we know how many times because we got the count. Then it puts them into some kind of structure, lines.tLine_no, and tLine_no starts at, it says it starts at 0, but you notice before we do the first load, it goes to 1. So we're going to have line 1, line 2, line 3. There is no line 0. And they're all in this lines thing. Here. REXX calls that a stem. It's the REXX solution to arrays, but it's not quite the same. Let's look at this. Let's stare at this. Let's think hard. How do we know if the file exists? There's no real open, right? There's no open in here, and there's no stat. We've learned about stat system call when we learned about the stat for finding out how many bytes are in the file and whatever. We've got lines, and it does a C, but we don't really know what that does when when file name doesn't exist. Clearly 0 gets returned, so 0 is returned, and the lines gets a count of 0, and then they do a close. File name C close with stream. Okay, so RC is stream, and we didn't even, what is RC? I don't know. We didn't use it. But the logic is bad here because before we get the line count, we need to make sure the file exists. And so when you're faced with a problem like that in some language you've never used, it's time to go to the internet. Okay, how to test is a file exists under REXX MVS. MVS is a mainframe thing, so maybe we're going to have to say Regina REXX, determine if file exists, and we still get this hit, which is not useful. This is OO-REXX, that's some other implementation. Okay, here's something exists, query exists, stream test. Okay, let's try that. And it's on SourceForge where we were when we got it. So we'll open that in a new tab. Okay, then there's Rosetta code. Check that a file exists, but I don't see anything about REXX here. Okay, Regina REXX interpreter from Germany. In standard REXX, the end of file is detected by checking whether there is more data left, while in REXX checks for an end of file. Well, neither one of those is us. REXX tips and tricks. Check if a directory exists. Get the boot drive. That sounds kind of DOSy. You know, we'll put that in a tab, see what goes on. Okay, the REXX model from Oxford. Okay, that's supposed to be a good school. Standard REXX allows files to be accessed using the 7 functions: char in, char out, chars, line in, line out, lines, and stream. Okay, that's looking pretty good. Pop that, and let's try that. Introductory text. Blah, 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 blah. Wow, that's a lot. That's a wall of text to read. If a function encounters an I/O error and is unable to perform its function, then it will raise the not ready condition. This condition will be ignored unless it is trapped by signal on or call on. However, in all cases, it is possible to examine the most recent I/O error using the stream function. I think we need to take a look at the stream function. Ooh, FD open. This function is for accessing files which have already been opened by another program. No, that's not us. File no stream. Get the file descriptor associated with the name stream. No. We use this one, lines, for stream. If the stream is not already open, which is true, and does not name a file which can be read, that's true. 0 is returned. Okay, my guess on that was right. And the not ready condition is raised, but we didn't trap that because we don't know how. Okay, open. The file specified is open if possible, and the error code from the system call is returned. And they have file open mode and stream. Okay, this is looking like the real champion here, but we don't know if that's going to work in Regina REXX or not. And they say it's the same as this. Okay, and we saw the stream function already in this code somewhere. Yeah, we saw the stream and they did a close. So I think we got to do it like this. Okay, and then for mode, what kind of mode can we be? We're going to do a mode R for reading. Okay, this is looking like the best choice so far. So let's try it. We're going to do RC equals stream file name. And we got to come back over here and stream C open. And they don't have a comma here. They don't have a comma here, but they do have a comma file. So this call is equivalent to this and may be deleted in future releases. So yeah, we want to stick with the stream. Okay, time for a new internet search. Nope. Something about the Regina REXX interpreter. REXX tips and tricks. Regina trip files REXX. Stream operations. This is from the actual IBM. Oh, could we have some more pop-ups? Not? Okay. Open read. Okay, opens the name for read. And you notice this is just classic IBM documentation. Yes, they've made it into a cute web page and all that, but absolutely no example where I need it. I need an example of how to do this thing, and they don't have it. So, bummer, dude. Now, we got something down here. Open right. So it should be similar to this. Stream, whatever, see, open, and then we'll put read. Okay, I got a plan. Now, how do we print? Every time we wanted to do a print, it looks like they do a call char out, but those are all things that don't have a new line. I want a new line, and I haven't seen how to output a new line yet. So I'm going to split this code. I'm going to come over here and see list command. That ought to show. Here we go. Say, and then something in quotes, and they use single quotes in this stuff. Okay, so we can say RC equal, and then RC. Now, can we put two things on one say? I don't really know, but I don't see why we couldn't. And this is one of those times where you might use this. And we're looking for any example of say that has more than one thing on it. They join things together with a double pipe like SQL. Oh, I can do that. Why would they be like SQL? SQL was also invented at IBM, if you don't know. Okay, so we can do it. That's going to print RC equal and the RC, and this is not going to fix anything, but it's going to let us debug because we can't run the debugger. So what do we have to do this? We have to edit a file that doesn't exist and see what RC says, and then we have to edit a file that does exist and see what RC says, and see if they're different. If they're different, I can do some kind of if statement based on RC, right? So, I've got a plan. So, we're going to run Fred, and we're going to say edit something that does exist, which was simple.txt. And let's look and see if we see our RC equal. Okay, we got RC equal ready. And everything else seems to work like it used to. So that didn't break anything. Now let's the one that doesn't exist, and we got error 2. Okay. So we have to make sure it says ready colon. And if it says ready colon, everything's good. And if it doesn't say ready colon, it's not good. Simple enough. I thought it would come back with a result code number, but it comes back with a result code string. Clearly ready, and there's no more information. This one is error number 2. And if we had a special mainframe documentation book, we could probably decode the 2 and find out that means no such file. We don't care. All we care about is either we can open it and we keep going, or we can't open it and we're just going to say can't open it. We don't care if we can't open it because it's not there, or it's permission denied, or it's a directory. I don't care. If I can't open it, I can't open it. That's not wonderful coding, but that's much better than what we have now, which is silently wipe out the buffer and don't tell me anything. That's not good. Okay, so we go into fred.rex and we look for our RC equal that we just typed in, and so now we can do our if RC. Now, how do we do an if to compare a string? We don't know yet. These are stop, lines, line count. Those are numbers. We need an if with a string. Okay, that takes the length of the string. Mm-hmm. Hmm. 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 Okay, we could do a select when. Maybe. That looks like the only string comparison in the program that I've seen so far. I wish you were here. You could point to it and tell me, oh, there it is on the screen, John. But nobody, everybody's watching remotely. So, okay, this a length. That's a start. Yeah, they don't have any if that compares strings in this program. Some people would get depressed. Some people would just stop and say, I have to have a book on REXX. And a book on REXX would really help. Okay, I won't lie to you. It'd be wonderful to have a book on REXX, but we don't have one. So let's just try 2 equals, which is pretty standard these days, and see if that works. And the other thing we can do is we can say, show me all the lines that have if. Do any of these have a, oh, they use a single equal. Single equal. Okay. So we don't use a double equal. We use a single equal. And this language is very old. It's before they worried about it. So if RC equal, what was the good answer? Ready. If RC equal ready, that's the good thing. Then, so how do we do a not equal? Do we have a not equal anywhere? We don't. Do we have a not equal anywhere? We don't. We don't know how to do a not equal. That's something we can search for. You know, so now this one, oh look, this is 395. It's old. Okay, REXX.io model. This was helpful. I'm going to bookmark that. This was helpful. They did have examples, but they were at the bottom of the page and they don't say much. But okay, it was there. And you notice this is from ZOS, you know, $1 million mainframe. So, REXX still is used today. REXX tips and tricks. That is a wall of text. That's not what we need right. We might need it someday, but we don't need it now. Okay, this is where we did. They have an exist command, not recognized. Yeah, okay, we don't want that. Okay. REXX if not equal operator. REXX operators. Arithmetic, comparison, equal, exactly equal, identical, equal, numerically, or when padded. Not exactly equal. How am I going to type that sucker in? Oh, I can use a slash. Okay, not equal. Slash equal is going to do it. And it looks like we probably, I'm not sure what exactly equal. Oh, identical would be the same memory location. We don't want that. Okay, but we do want this. I worry about not exactly equal, but here we go. It's not exactly equal, just kind of equal. Okay. I'm joking a little bit about the English, but there it is. If that, then we need to give some message. And we'll figure out what in a minute. And then we're going to return. And how do we end the if? Do we say end if? Do we say fee? We need to find a multi-line. Here's the multi-line if. If, else. They don't have anything. Ah, do end. Okay, if then do say this stuff and have an end. And the else is just keep going. Okay, what message do we want to get? Cannot open file name. I like it. And, you know, I'm coding REXX and I don't know REXX officially. So, Fred.REXX. Oh, invalid expression detected at the equal on line 127. Oh, and we were feeling so good about it. Okay, 127. He didn't like that. So that makes me wonder if we need to say Regina REXX, not equal operator. Because we used this one, which was supposed to work, and I don't know how to type that character on a regular keyboard. I'm not saying it's impossible, but I don't know how to do it. Okay, they're saying maybe we could use a backslash. I'll try a backslash. So let's first try a file we know is there and make sure we don't get any message. RC is ready and the buffer loaded. Cannot open stupid text. Buffer was unchanged. Yes, we have fixed it. All we need to do is remove this error debugging code. So Fred.REXX, we look for our RC equal quote double pipe, and that's debugging code. And you might say, I might need that again. If you need it again, find it again. But that's the not equal, and we didn't have any not equals in the program, I don't think. Oh, we did. We had one here with a character and an F, and I just totally didn't see it. Okay. But we fixed the edit command bug using REXX and using a little bit of internet help. Are we done with Fred? We're not done with Fred. Why aren't we done with Fred? I think we hit some bug where we had 33333, right? And if we look back here, can we? Yeah, this one. When I deleted the backwards range, we got this craziness. So we need to catch that bug. And that's going to be in some delete. Okay, but we fixed one bug. So let's find out what D does. D says del command. Okay, del command. And we noticed they had a colon after a subroutine name. There it is. Now, if you look at this code, there's some pretty dumb stuff in here. Right? If then do, and we're going to return end. That's pretty normal. Else, we do this stuff, and there's no return in there. We could just drop this stuff. Okay. That's 1. Okay, we check if start is less than 1, we say something and we return. If the length of stop is 0, stop is start. If start is greater than the number of lines that exist, we return. If stop is greater than the, if start start is greater than the last line, we return. If stop is greater than the last line, then stop is the last line. Okay, so if start is less than 1, we give an error. Then we set stop and start. Okay, right here, this is where we're going to put our check. If stop, let's see, if start is greater than stop, right? We started on 4 and we stopped on 2. If we do 3 and 3, it's not greater than, it'll work. But if we do 3 and 2, it'll fail. If we do 3 and 4, it won't be. Okay, this is what we want. Then do say, I don't know what. Let's see what the Python did. Python did if end is less than start. So that's the same thing as this, but we want to keep the same logic. So let's say if stop is less than start, right? If end is less than, say, and we want to print the same kind of message. End of range cannot be less than start of range. And that does a return, we'll do a return. Okay, I think that's going to fix that. So we're going to edit simple.text list. We're going to D a 4 minus 2. End of range cannot be less than start of range. Buffer's okay, it's not destroyed. Did that break single line delete? It did not. Can I delete 2 through 2? I can. And a normal forward range works. Good. We haven't tested some of the border cases yet. All right. Delete the first line. Okay. Delete the last line. Okay. Delete a range with the first but not the last. Okay. And now I gotta load again. Okay, delete one that has the end, but not the beginning. That works. Delete everything that's there with a range. That works. That works. Okay, so we've fixed E, we've fixed D. In the other programs, we didn't have any trouble with A, but let's see. Let's add after 1. Let's add after the last line. Let's add before the first line. Okay, so add doesn't have any trouble. It seems to work. Delete's working. And I don't think we have much else. So and the help works. So we've tested A, D, E, H, L, and everything works. Are there bugs still? Perhaps, but we've we fixed the big ones we found. And we did it without a REXX textbook. It turns out on the Regina website you can get a PDF with a complete manual. But to learn it, you'd have to spend days reading the manual, which we don't want to do right now. Just to fix a few simple bugs. And we can do that even in a language we don't know, as long as the language isn't too weird. And REXX is not too weird. It's a little weird. You know, backslash equal for not equal, that's a little weird. But it's not too bad. I'm feeling pretty good. We have done a good job on Fred C. It had a lot of bugs. Fred Pi, we got that fixed up. Fred REXX is fixed up. I hope you'll come back in our next video and we'll tackle Fred SH. You notice it's pretty long compared to the Python and the REXX versions, but it's shorter than the C version. And that's going to be in some kind of Bourne shell. We can take a look, we can cheat and take a look at the first line. If I remember to put the number, I made this bug in another video. Okay, so this is written in Bash. Bash is a pretty powerful modern shell, has associative arrays and all that stuff, so shouldn't be too bad. Please come back for the next video and you can see how bad it really is. Until then, we appreciate you coming to watch our videos, and thank you for listening.